I'd like to welcome our two next speakers and panelists. Thank you very much for joining us. We have Jesper Jarnhäll. You are the CEO. You've got actually a long history in the energy space, but right now you're here as the CEO of Swedish Modular Reactors Limited. That's correct, right?
That is correct.
So it's a nice abbreviation there with SMR, fits nicely. And then we have also Martin Darelius. You are the what's the title? Is it Chief Strategist or something like that for generation at Vattenfall? And also muted?
Yeah, sorry. I'm responsible for strategy development within BA Generation, so the business area for a nuclear department.
Excellent. Thank you so much for being with us. So I'd like you first to give you 10 minutes each to give us your perspectives and insights on what you're doing in this field. Then we can have a discussion amongst our three. So starting with you, Jesper, the floor is yours.
Thank you very much, Marcus. So thank you very much for the opportunity to be here and present Uniper and myself and Uniper in this conference on nuclear beyond electricity. It's really interesting, and exactly as you said. So my name is Jesper Jarnhäll, and I am the managing director of the company Swedish Modular Reactors AB. So we were really pleased when we got the abbreviation to spell out like that, because that's exactly what we're trying to do, bringing and launching the SMR technology into the market by working with a lead fast cooled reactor in this area. So I'd just like to take you with me on a little journey on what we're doing in SMR, and with focus also on the beyond electricity, and give some examples of what we're doing within Uniper in this field. But starting from a and give the proper angle to entry point, this is truly sort of a matter of urgency. Maybe it's somewhat preaching a little bit to the choirs in this crowd, but we all know the growing electricity usage, and in order to be able to have the rapid decarbonization of our societies, we really need to get some additional electrification of our societies, and we're looking at doubling the current electricity consumption over the next 20 to 30 years. It's a great contribution to our energy systems of introducing, the additional renewable energy sources. A lot of countries is, successfully transitioning into this, into the usage of additional renewables, but it also introduces some kind of, the volatility of the production, introduces some balancing demand and production complexity, and that really emphasizes the need of getting new steady baseload power from clean and energy sources. And going forward on that, looking at the challenge today is the current way that we're producing energy cannot be sustained. And just looking at the world's electricity production today, is more than 50% of it is fossil dependent. If we also start including the energy production for transport, industry, and heating, we're looking at more than 80% of the world's energy production is fossil dependent. So to achieve the net zero, the decarbonization of power, transport, industry, and heating is truly pivotal. And that also brings us to why the nuclear beyond electricity is so relevant. And the way forward and paving that way is the electrification of our societies. And today the 450 commercial nuclear reactors is producing approximately 10% of the world's electricity. For us, the missing piece of the puzzle in order to meet that increasing electricity demand is spelled SMR, so the small modular reactors coming into the play. And the reactor that I am working with, or we are working with in the collaboration, is the Sealer 55. It's a 55 megawatt electric small reactor. It's truly small in size. It's now the reactor vessel is basically a 5 times 5 meter size. And this technology is truly, offers CO2-free, flexible baseload power generation, a stable source that would also support additional builds of renewable assets. And this technology aims also to be truly scalable and with fast deployment. And coming to that kind of fast deployment, and that's going to be, enabled through the industrial serial production, which improves, or brings or removes a lot of the risks. Lower risk for investment, for sure. We're getting improved quality by being able to use standardized components and production methods. And that also shortens down time from when you place an order on this kind of unit until when it's going to be delivered. By being able to build them in the size that we are, we will be able to transport them on a normal truck from the factory. And that also reduces a lot of the on-site construction, which takes a lot of time today. So basically, if you get the building permits ready, it should go towards more of a plug-and-play kind of installation. And then, of course, by design, it is also modular. So having one reactor gives you the 55 megawatt output, but then you can scale that up to have 10 or 20 units in serial production. Then you're reaching up to the 500, up to a 1,000 megawatts of capacity in one site. And this could be deployable both on-grid or off-grid. And we have some use cases in like Canadian mining that is truly off-grid and using fossil fuels today. Just to give some and put the lead cold reactors in some perspective, there is a lot of companies working on the SMR technologies today. And by definition, a small modular reactors today is that it should just be something less than 300 megawatts of capacity. We have a new scale, which is a very well-known company who is already, in the commercialization phase of their water-cooled reactors. We're looking at helium-cooled reactors coming online in due course of the year. And next in phase, we see the lead-cooled reactors. But now we are actually truly coming down in size for the first time. The new scale water reactor is about 75 megawatts of electric capacity, if I have the right information. And given the lead-cooled, the benefits from having a lead-cooled reactor and operating at very high temperatures, over 500 degrees Celsius, we can now start scaling down the facility to be able to have this industrial approach on manufacturing. But maybe coming to the question of the cascading effects and what is that electricity or beyond electricity. And it's very true that we will have to decarbonize not only the power generation, but also the industry as such, transports, heating and cooling, and so forth. And the Sealer 55 truly offers this multifaceted kind of innovation. We have examples of and started also doing on the design phase, some scaling down of the reactor from the 55 to a much smaller reactor that could be used on large shipping or marine transport. For sure, the technology could be deployed in the energy system where it's making the most use in close to large energy consuming customers. But also having that 500-degree high temperature steam gives a very good advantage of the potential of using high temperature electrolyzers, producing hydrogen at way lower costs than in a conventional electrolyzer. And then for sure also the district heating part, but I will come back to that in a minute. Giving some examples, and I really think that hydrogen to green steel in the activities in northern part of Sweden serves as a very good example. It's an impressive company that is now taking the ambition of making green steel. But we also know that they will create a single point in the energy system that will basically consume like 20 to 30% of Sweden's electricity production at one point. So this would be an ideal customer, to be supplied and build that kind of local production of a Sealer 55 for a potential as an on-site generation, producing CO2-free electrons and high-temperature electrolyzer to support that kind of transition as an ideal use case. But what we within Uniper is doing in this field is that we are now in a project together with the ABB, jointly also with the Luleå Harbor and the Luleå Energy, together with the logistics company EKL, the shipping company, where we are looking now to build local hydrogen production. It is in the area of Luleå, where we will have H2GS among other steel companies. And what we want to do here is to build a facility that is producing a clean hydrogen based and the derivative of methanol or e-fuels, by being able to support also the transition of decarbonizing the entire value chain. So to give that kind of fuel to the shipping that is taking the green steel from Luleå down into to the mainland Europe and for international exports. Additional projects that we are doing is on the sustainable aviation fuels. Our project SAF. We are now in final site selection of doing an investment, a pretty substantial investment that is going to combine the technologies of gasification of biomass to create carbon monoxide in combination with clean power and electrolyzers, producing that hydrogen, taking us into a chemical reaction of Fischer-Tropsch that is producing then, a CO2-free fuels for either the flights or for marine sector. The final site selection, we are heading down towards this. We do have some projects on international ground, but we actually have a very interesting sites also in Sweden, and hopefully, from my own personal perspective, it would be really, really nice if we get this project here. And from an SMR perspective, it would serve as a very good use case as well. Last but not least, coming to the Sealer 55 potential of operating at that kind of high temperature, that's a high quality heat, to be honest. And that truly serves as a potential to taking combustion out of the equation when it comes to district heating. So burning waste and biomass could be something for the past, should this technology be deployed and be able to be close to our cities as well. Looking a little bit on the development plan for the Sealer 55, the roadmap currently as it stands is that Project Sunrise is managed by the Royal Institute of Technology, KTH, that is together with us for sure, doing some design and testing and qualification of materials, of components, and also production techniques. Within the company that I'm managing, we have applied for state funding of erecting and building the electric demonstration plant, or the mock-up Sealer Electric, which is a prototype. And given if Project Sunrise and the outcome of Sealer Electric, which is now scaling up Sunrise on commercial basis, turns out to be to verify the proof points. We are very much looking forward going down the timeline to construct then a demonstration reactor that is referred to here as Sealer D, in order to have a commercial Sealer 55 product by 2030, start of 2030. And that is truly be a scalable innovation, and it's very rewarding to work in this kind of environment, bringing all the experts together from the academia, from business, from society, and we're planning to build this Sealer E at the Uniper's owned site in Oskarshamn at OKG, where we operate the existing nuclear power facility today. So in order to be able to stop using the fossil fuels, we are really dependent on new baseload power. So Sealer 55 is a modular reactor and can offer a highly competitive power generation for the future. I also want to, take the opportunity to pass along a message, and we're playing catch up on climate, but it also, the time to act truly is now, and technology is moving way faster than legislation. And our prototype of Sealer E and Sealer D is reaching final stage. It's ready to be implemented and trusted, so we could truly take the next step towards tomorrow's energy systems. And my personal belief, at least, is by starting shaping the energy system of tomorrow, we could achieve the net zero by 2050. And it's bridging the past technology into a big step or a leap forward for future technology on SMRs.
Thanks, Jesper.
Thank you.
So please, Martin, the floor is yours.
First, thanks, Jesper, for a very good presentation. And I truly agree with what you described as the challenge of society and the energy system, and the challenges that it faces if we are to reach the climate targets. Vattenfall, of course, as with Uniper, our goal is to be climate smarter living, and by that we are determined to enable a fossil-free living within one generation. And now, walking the talk, as we say, we have now increased our internal emission reduction targets in Vattenfall to be in line with the 1.3 degree Celsius scenarios. And so, to succeed with that target, we must, of course, be fossil-free ourselves in our business. We have now a clear plan for that, but of course that's not enough. Our supply chain and the energy system that we work in, we must also be fossil-free, and that's why we're looking beyond our own electricity production to see where we really can make a difference. One example of that is the project that was mentioned by Jesper, is the hybrid project that we're together with SSAB and LKAB. In a, I would say, unique joint effort, try to change the way that we produce iron and steel in Sweden, and we are using fossil-free hydrogen to produce that. And we truly hope that that could fly and make way also in the rest of the world on how you. No, I have no presentation, so you just need to listen to me. Another example is the Power to X project, and that we have together with Shell, Lanzatech, and SAS to produce sustainable air fuel. We have cited our. Sorry, now my little boy came here and disturbed me. The drawback of COVID, having children at home, and we have. And the target for us is to produce 60,000 tons of sustainable air fuel per year using fossil-free hydrogen. Why do I mention this when we are to talk about SMRs? Well, it's because we truly believe that this type of industry cooperation are necessary to reach our climate targets and decarbonize the whole society. So when we look at SMRs, we don't only look at them as an electricity producer, but how they could fit into an energy system helping decarbonize society. Truly believe that the SMR has a place in this future energy system, just as the big conventional reactors. We also want to highlight that, but where they will be used depends on the market setup, grid dynamics, and what we want to produce with them. So Vattenfall has analyzed how we see the future role of SMRs, and we also have seen how we could fill this future demand in what we call the electricity revolution, or electrification revolution. And our conclusion is that all fossil-free energy sources will be needed if we are to fill this gap. And in order to ensure that we now building competence and knowledge regarding the technology, we are starting such projects. And for example, as many of you know, we have a build competence, and we have supporting the Estonian startup company Fermi that are investigating the possibility for commissioning an SMR in Estonia in the middle of the 30s. And we support them with our knowledge and experience from our nuclear operation in Sweden. But saying that, we also realize when we do this that in order for SMRs to actually be realized on the market, we see that regulation must be adapted for the design of the SMR, a little bit as Jesper said, and we see that the current regulation in the different markets are not adapted for the the properties of the SMR, and that needs to be adapted. Otherwise, this will take a long time. We also see that the market model must actually value the true properties and gains of nuclear energy. And if that is not correct, then it will be very hard for nuclear. And that is not specific for SMR, but nuclear as a whole. And that also, of course, there needs to be a solid support from society in order to go nuclear. Otherwise, it also will be there. So those three things we see that we need to be on different markets. But on those markets and in those places where these three things happen, the SMRs and nuclear definitely have a role to play in the future. I think I'll stop there because then we have a little bit up on time again with what was said and open for questions.
Yeah, thanks Martin as well, and thanks to Jesper. So Martin, starting with you, you mentioned that the kind of the future of SMRs depend on the market and how they fit in. But do you think that is kind of a requirement or for SMRs to be successful? This sort of dual or even multiple production of different carriers, so heat and electricity, for example, at the same time, and possibly hydrogen. Is that the way forward? So we shouldn't really look at SMRs as a way?
I wouldn't say that. But it's a benefit, and I think also we will see different types of SMR solutions and different types of technologies that will fit into. I mean, just Google SMR and see how many hits you get and how many technologies there are. I don't say that all those technologies will be realized, but there will be SMRs for different purposes and different solutions. Yeah.
No, sorry, go ahead.
So in some cases, we will look for SMRs to be integrated in industrial clusters, supplying heat and hydrogen and electricity. In some other parts, SMRs will be used off-grid, as Jesper was talking. And in other ways, we will use SMR as a way to more reduce the investment burden, so to say, because it's a lower initial investment burden. So it will depend on the market setup and in what way we want to use an SMR. And that is the true. It's a little bit of a Swiss Army knife. You can use the SMR, and that maybe also that is something for us to remember in industry, that it can solve problems, but the fundamental behind that is actually a nuclear reactor is still there. We need to not forget that.
And do you, so picking up on that, do you see a role for Vattenfall to sort of go in and maybe build and even operate nuclear plants jointly with an industry?
I mean, that is, of course, a little bit premature to say. And what we have said in that for example, going to Sweden or in Europe at all, we say now that it's premature to roll anything out at the moment. We don't see how the future will and the technology development. We are investigating how nuclear can fit in a new energy system and in the new energy world. SMR is one of those things that we're investigating. But to say now in which technology we will invest and how we will do it is something that we see that maybe we don't need to do that in a couple of years. And now we're just enhancing our knowledge, also trying to see where is society headed. What would regulators and politicians actually want to have? Because it's very crucial that we feel a solid support for this if we are to do it. I mean, we should still remember that building a nuclear reactor is a very long-term obligation, and you need to have a full support from society if you are to take that obligation as a private company.
And thanks, Martin. Turning to you, Jesper, sort of the question in the same vein. You mentioned a couple of those projects up north in Sweden, and specifically H2 H2GS, the green steel company there. Do you actually have? It sounded like as though you've had talks with them. Is that what I heard? And now you actually muted. Sorry, Jesper.
No, sorry. No, the H2GS serves as a very good example of where this technology could, be deployed in the energy system to create a lot of value. So that is, but that is also saying, and from a Uniper perspective, and I agree with Martin, there's so much things that needs to be, settled and in terms of regulatory environment and legislation before doing that. But we do not rule out, being able to support our customers by building on-site generation. Then the question for me becomes, where will these kind of assets sit in the future? Following the trend of what we're seeing of all the renewable assets and the companies now that is building and erecting it, usually it's a build, sell, and operate kind of business model that we're seeing. And these assets sits usually, on large institutional investors. And that is also very beneficial for the end customers in general, because we're seeing a low cost capital coming into the energy sector, pushing down prices, etc. And we all know the marginal cost of that kind of production. So the question is, for me, is where will these assets sit in the future? We are developing it now. We want to build the SMRs. We have a plan to be part of with the SMR AB to support the technology development of a specific technology. That is the lead-cooled reactors, but Uniper as an energy company is looking into the SMR space at a wider approach and being more technology neutral, of saying, well, we could choose water-cooled reactors, lead-cooled reactors, or salt-cooled reactors. That's kind of a race to market on different technologies. So that's where we stand on that one.
Okay, so and you both mentioned regulation here, so I'm a bit curious here. What kind of changes do you think we need to see in order for SMR to be a bit viable to invest in the market? Starting with you, Martin.
First of all, you need to credit passive safety system. We don't do that. For example, in Sweden, we don't do that. So that,
sorry, could you say again, please?
Sorry, we need to credit passive safety systems and safety features. If we don't do that, we also need to credit other things in the SMR. We need maybe one of the advantages that we hope for is that we can have an international license. If we are to license an SMR in each and every country, that will also be some of the advantages of industrial manufacturing will then be lost if we are to do national adaptations for all technologies. So I think those two we need to solve in one way or another.
So basically standardizing. So if you license your technology in, say, Belgium, it's automatically possible to use it in another country?
Within the European Union or whatever. Yeah.
Okay. And do you share, Jesper, those two sort of main wishes, if you wish? And please, you're muted again.
It's automatically muting me.
I think it's God or our conference manager who mutes you in between.
No, I fully agree with Martin on that one. From an international perspective, so the market for this product truly is a global market. But coming back to a Swedish perspective, we are now only allowed to build this kind of technology at existing sites where we operate nuclear today. But and we should definitely do that as well. But the greater value of being able to use the SMR distributed to create that value is specifically where it's needed. And then I come back to what Martin already mentioned, saying that different SMR will be used for different purposes. Let's say that we could put an SMR next to a customer like H2GS to reduce that kind of spike and bottleneck that it will introduce. Well, then you're looking at producing both electricity and steam in order to create your efficient hydrogen from a high temperature electrolyzer. But if you put an SMR in a connection point next to a large scale offshore wind farm, then that SMR would serve to create stability in the energy system from a volatile production coming from offshore. Or if you place that SMR next to a city heavily dependent on heating, so you will configure your SMR accordingly to where in the energy system it's at, and that also needs to be supported by the new legislation.
Thank you so much to both of you. It's been a great talk, and we haven't heard the last, I think, about your plans. Or at least I hope not. So all the best of luck.
I can just comment on one. I see a question from Nils-Olof Jonsson that I can just mention is that our CEO Anna Borg published 10 points to society where we think that society needs to step up and politicians need to step up, and that was done in the 6th of December, I think. And one of those points was actually that we need to update the regulations for nuclear, especially SMRs. The question from Nils-Olof was if Vattenfall and Uniper are trying to initiate changes in the laws. And that is, we have put that forward for the politicians in Sweden and see that as one of the 10 most important points in order to actually enable a change of the energy system.
Thanks, Martin. Yeah, I also see some really good questions in the chat, and if you have a chance, please feel free to answer those in writing there, both of you. Yeah, so thanks again. We have to move on to our last speaker in the program, but I'll see you soon.
Thank you very much.